Hi everybody. So I'm excited that I get to teach you again. It's just kind of sad because I don't get to see your beautiful faces. For this first lesson, I want you to know I'm going to keep it real simple today. I don't want you to be overwhelmed really with any of these lessons. We do have to keep going with things that you haven't quite seen yet. Now this lesson is continuing on from what we were working on before spring break. So there are going to be things in this lesson that you've seen before, and it's just kind of a lesson that puts everything together. So in order to get through this lesson, I'm just going to take it in chunks, and I'm going to do just a little bit each day. So it's going to take us a few different days to get through this lesson because I do not want to overload your brains, and I don't want to overwhelm you by any means. So I'm going to do just a little bit today, and then just a little bit the next few days. And then I'm going to ask you to do a little bit for me, but nothing overwhelming, okay? So actually what you're going to be doing for me is typically less than you would do, in a class time. So I want to keep the videos kind of short. If a video is a little bit longer, I'll give you a couple days to watch it. So that way you have a little bit of flexibility there. But these first few videos are going to be a little bit shorter. I'm only going to do just a little bit at a time. Okay, so this first lesson here that I want to teach you has to do with finding all the zeros of different polynomial functions. So when you look at this guy right here, this is a polynomial, and we're going to find all of its zeros. And when you look at this guy, this is a polynomial, and we're going to find all of its zeros. And so we're going to be doing that in the next several days. But today I'm going to start off real easy. So first thing I want you to know is if you have what's called a cubic function. That's when the highest exponent is a 3. And if the highest exponent is a 3, then there's going to be 3 zeros. So this graph here, you can actually see all 3 zeros. Remember, the zeros are where the graph touches the x-axis, and you see it touch 3 times. 1, 2, 3. So I just want you to know that whatever the highest exponent is, that's how many zeros there's going to be. Now, when you actually see it touch the x-axis 3 times, then that means all the zeros are real numbers, no i's. But if you don't see it touch the graph 3 times, and you know there should be 3 answers, then maybe there will be some imaginary answers as well. Okay? Now, as far as you taking notes goes, I don't want you to feel like you have to take notes. You can just kind of watch and soak it in. If you have the capability of printing these notes out from my Canvas calendar and write on them, you're welcome to do that. Otherwise, you can just kind of watch and just soak it all in, and then if you have to replay me doing a problem for you to remember how to do it, down the road, then you can just do that. So don't feel like you need to take notes, okay? And if you want to take notes, then take notes. So one thing I want you to know is that complex numbers are a mixture of your imaginary numbers and your real numbers. So real numbers are the kind of numbers you've known about since you were a little kid. And then the imaginary numbers, those are your i's. And the two made up together are called complex numbers. So down here, I'm trying to get you to tell me how many complex roots there are. And when it says how many complex roots, it's really asking how many zeros are there. You just have to remember that some zeros are real numbers and some zeros are imaginary. And whatever that highest exponent is, that's how many complex roots or how many zeros there are. So in this problem here, in this little box, since the highest exponent is a 6, then that means there's 6 complex roots or there's 6 zeros. So if I was to graph this, it could touch the x-axis 6 places, like how this one touched the x-axis 3 places. Well, if it touched the x-axis 6 places, then all of those answers would be real. But if you don't see it touch 6 times, then that means you probably have some imaginary answers as well, which is why we call them complex roots, because complex roots are made up of your imaginary answers and your real. Okay, so down here, when it says how many complex roots are there, it wants to know how many zeros. So you just look at the highest exponent, and whatever the highest exponent is, that's how many complex roots or how many zeros the problem has. Okay, I'm going to flip the page. any of you happen to be following. So this one here, how many complex roots would you tell me that there is? There's 6. Whatever the highest exponent is, that's how many complex roots, also known as zeros. And what about this one? How many complex roots do you think there's going to be? There's going to be 7. Whatever the highest exponent is, that's how many complex roots. Okay, so today, the only couple problems I'm going to have us do where we actually find the roots, we're going to do completely with the graphing calculator. We're not going to have to do any math whatsoever. I'll save that for tomorrow. Okay, so first we're going to look at this number 2, but I want to change its equation because I want to make it so where it's really easy to do on the graphing calculator. All right, so let's change the equation to x to the 4th minus 10x squared plus 9. So if you can see these notes, they tell you to do some stuff in the directions that I'm not going to do because I want to make your life easier than I would have made it if I would have had you in class. Okay, so the first thing we're going to do is we're going to graph this. I know that there should be 4 answers total. So I want to see if I can find all 4 on the calculator. And if I can, then we're done and we'll call it a day. Now, if I can't find all 4 answers on the calculator, then that's when we have to do things like synthetic division, the square root method, and quadratic formula. Okay, but I'm not going to do that to you today. So on your Canvas calendar, I have put a link to get to this website that shows you a graphing calculator. So I have this link on your Canvas calendar, and so when you type it in, then you're able to access a calculator just like this. So I'm going to do this problem on this calculator so you kind of know how to do it for yourself on your computer. So the equation is x to the 4th. So I'm going to take my mouse. Here's my little mouse. This is my x. So x, and then above the division bar is this little caret, and that raises it to any power you want. So I'm going to hit that guy to the 4th power. And then I have to right arrow to get the cursor to drop. So now the cursor is dropped. So after x to the 4th, we had minus 10x squared. So I'm going to put minus, and then 10, and then here's my x. The squared, I can do this guy or I can go to this guy, but I'm going to do this guy right here where it says x squared. And then behind that it said plus 9. So I'm going to put plus 9. So I'm going to hit graph, and hopefully it touches the x-axis in 4 nice places. So right here, the top right corner, I'm going to hit graph, and it looks like it touches in 4 nice places. 1, 2, 3, 4, which is great. Now, this looks like a -3, this looks like -1, this looks like +1, and this looks like +3. But to know for certain, I want to go to the table. So I have to go second, graph. And I want to be looking for zeros in my y column. So you may have to arrow up or arrow down in order to see all the numbers that you want. And sure enough, -3 is an answer because there's a 0 in the y column. -1 is an answer because there's a 0 in the y column. +1 is an answer because there's a 0 in the y column. And +3 is an answer because there's a 0 in the y column. So -3, -1, +1, and +3. Okay, so I'm going to write those down. So I'm going to write x equals -3, -1, +1, and +3. So today I want to keep it real easy, and I just want you to know that the highest exponent is how many zeros or complex roots you should get. And if you can see all of them in the calculator, then we're done. And then tomorrow, we're not going to be able to see all of them in the calculator, so then we'll start doing synthetic division, and we might have to do quadratic formula or square root method. Okay, I'm going to show you one more. So looking at this one here, how many zeros should we have when we're done? We should have 3 when we're done. So let's see if they're going to come out nice. So I'm going to put this in my graphing calculator. So once again, you can access this with the link that I gave you. So I'm going to go to y equals, and I'm going to hit clear over here to clear that equation. And this was 3x to the 3rd. So 3 x, raise it to the third power. Now I have to right arrow to get that cursor down. And then minus 12x. Minus 12x. And I'm going to hit graph. Let's hope it touches in 3 nice locations. It looks like it does. 1, 2, 3. So it looks like -2, 0, and 2. But to know for certain, I'm going to go to the table. So second graph. And yep, -2 is an answer because there's a 0 in the y column. 0 is an answer because there's a 0 in the y column. And 2 is an answer because there's a 0 in the y column. And those are our answers. So we've got x equals -2, 0, and 2. And we're done. And that's the first lesson. So now I'm going to have you do a little quizzes for me. It's not very long, and I've got the link on the Canvas calendar. And so that's all for today. And then we're just going to do little bits at a time. So hopefully just a little bit of learning won't be too overwhelming. And you will need to put that graphing calculator in your computer so that way you can access it. And that's it for today. Smiley face.